In this video, we're going to look at graphing trig transformations. So what happens to the sine and cosine graphs as we do stuff to it? So we got 4 examples here. We're going to take a peek at these graphs in a different uh, program. And so we're going to figure out what does the 4 do in front, what does the 3 do on the inside, what does the 2 do on the outside, and what does the minus pi do on the inside. So this might be, you might remember how to do this based on transformations of other parent graphs, but if you're not sure, let's take a peek at this. So let's look at the graphs. We don't need that one. We're looking for this one. And so here's the graph y equals sine of x. And I think on my notes before I said sine of theta. So the first one says y equals 4 times sine of x. So what does the 4 do? So let's highlight this one. And you can see this bluish purplish one is just like the purple sine wave, or red or whatever that color is. It's just like the other one, except instead of going up to 1, it goes up to 4. And then it swoops down to -4, and it goes up to +4 again, but it crosses the x-axis at the exact same spots as the original sine wave. So let's just kind of change this 4 and see what happens. Let's say we made this 2. Looks like it makes it just a little bit taller. What about if we made it 3? It makes it even taller than 2. What about 0.5? It looks like it makes it shorter. So this number out in front, this is making it stretched out. So in this case, it's -3 pi over 2.5. It's making it stretched out in the y direction. So if we look at our notes, this first one is a vertical stretch by 4, and what this means is the amplitude is now going to be 4. So before the amplitude is 1 with just a 1 in front here, now this changes the amplitude to 4, and this is kind of the main idea for this lesson, that you can identify the amplitude based on this equation. Okay, let's look at the next one. Let's go back to our graphs. And by the way, this is called Desmos. It's a really nice graphing calculator. It's free online. I'd highly encourage you to use this. So let's unhighlight that one. Let's look at sine of 3x. So what does this do to the sine equation? Okay, it looks like it makes it more compressed. So it makes it more wavy. It happens more frequently. There's one full sine cycle once we get to here, whatever this is. Then it happens again. Then it happens a third time once we get to 2 pi. So this 3, I'm thinking it makes 3 cycles, 3 sine cycles until we get to 2 pi. So let me change that to a 2 and see if that makes it 2 cycles between 0 and 2 pi. Let's see, we go up, down, up. Yep, 1, 2. So I'm guessing if I put a 10 here, it'd have a bunch of cycles between 0 and 2 pi, and I'm assuming that's going to be 10. Okay, so this number in here, what this does is it changes the period. The period is how long it takes to do one full cycle. So let's look at our notes again. The 3 on the inside, that's called a horizontal compression. It compresses the graph horizontally. And the period is now, instead of 2 pi, our normal period, this period is 2 pi over 3. So you take 2 pi divided by the multiplier here, and that gives you what the period is. So if you like thinking in terms of degrees, the normal period is 360. Now we take 360 divided by 3 and it'd be 120 degrees. Okay, let's take a look at the next one, sine theta plus 2. So I'm going to unhighlight that one. Let's look at sine theta plus 2. Okay, so now it appeared and it looks like it's just hovering up above it. So the plus 2, I'm guessing, moves it up 2 because it looks like the exact same sine wave, except it's 2 above it. So I'm pretty sure that's right. Let's do plus 1. Yep, that's just 1 up above it. What if we did -4? Yep, that goes 4 below. So That means if we add or subtract something on the outside, that's shifting it up or down. So in our notes here, sine theta plus 2, that's going to be a vertical translation up 2. Okay, and then the next one here, sine of theta minus pi. What does this minus pi do? So let's take a peek at that one. It says sine of theta minus pi, and here it says x. We'll highlight that, and what the heck just happened there? This blue one showed up, and now it looks like a double helix. I'm not sure. So let's play with this for a little bit. Let's change this minus pi to minus pi over 6. Okay. It looks like it shifted to the right and left, maybe? It's not moved up or down. So let's make this, instead of pi over 6, let's make it pi over 4. Okay, so if we make it a bigger number, it's shifting more to the right, it looks like. So pi over 2, there we go, it's shifted pi over 2 to the right. If we make this, let's say pi over 3, it should shift it, okay, a little bit to the left from where we were. So this number, theta minus whatever this is, this tells us how far it's shifting it to the right. So if I change this to a plus, I'm guessing it would shift it the other way. Yep, so it shifted it to the left. Okay, so in our notes, we would call this a horizontal translation to the right pi units. Okay, so one of the main things we want to talk about now is period and amplitude. So I've got a couple examples here. State the amplitude and period for these 4 examples. So let's do that together. I encourage you to pause the video, write these down, and then we'll go through the answers together, or you can try to figure them out on your own. Okay, so we've got y equals 3 cosine theta. We'll start with the amplitude. The amplitude of this guy is going to be just 3. It's this number out in front. That affects the amplitude. The period, well, the normal period is 2 pi. And since we're not multiplying by anything inside, the period is still 2 pi, or 360 if you want to think of it in terms of degrees. But we're going to be talking in terms of radians from now on. Okay, so here the amplitude is 4. That's the number out in front. And then the period is going to be 2 pi divided by 2. So it's going to end up being pi. So what this tells me is that this sine wave is going to make one full cycle every pi degrees, or pi radians, I mean, instead of 2 pi like it normally does. Okay, here the amplitude is 0.2, so it's going to be a shrunk down graph. And then the period is 2 pi divided by 0.5. Remember, if we divide by a fraction, this is 1/2, we multiply by the reciprocal. So this ends up being 4 pi. So this wave is going to be much more stretched out, like that. Okay, and then last one here, the amplitude is going to be 2/7, and the period is going to be 2 pi divided by 1/4. So that ends up being 8 pi. So this is going to be really stretched out. Okay, so now let's pull it all together. If we have something like this, where it says y equals 3 cosine 4 times, in parentheses, theta plus pi over 2, close parentheses, minus 1. Each of these parts does something special. So the number on the outside, that affects the amplitude. That's called a vertical stretch by 3. The multiplier on the inside of the parentheses, this 4, that's the horizontal compression. That's going to affect the period. So we take our normal period, 2 pi, and divide it by 4. So now the period is going to be pi over 2, or 1/2 pi. The pi over 2 on the inside, that moves it left and right. If it's plus, that's going to move it to the left. So this is going to be a horizontal translation to the left, pi over 2. And then the -1 on the outside, that moves it up or down. And since it's minus, it moves it down 1. Okay, so this is essentially all the transformations. Now we haven't talked about what if there's a minus sign out in front? And the minus sign acts just like it does on all the other transformations. This one here would reflect it over the x-axis. So maybe we could write that one down as well. So it's a reflection over, excuse me, over the x-axis. Okay, so if there's a minus sign on the outside, it's a reflection over the x-axis. If there was a minus sign on the inside, I'll kind of do that one in red. If this was a minus here, that would be a reflection over the y-axis. I'll abbreviate that, reflection over the y-axis. And this is the same as it would be with like a parabola and stuff like that. So the nice thing about this is it's not symmetric over the x or y-axis, so it's very noticeable if you have a minus here or a minus there. Okay, so that pretty much covers all of the transformations we'll deal with on the sine and cosine graphs.